All right, I have a little bit more to show you about thermal conductivity and heat conduction. I'll review a little bit of what I told you last time. I show a wall of thickness X, face area A. Perhaps it's not a wall, but a window. On the one side of the window, it might be bedroom air at a temperature T1, measured in degrees Celsius. On the other side of the window, cold February air, maybe. Temperature T2, measured, of course, still in degrees Celsius. The rate equation, R, will tell you how many joules each second pass through the wall from the bedroom to the outdoors. Ka times the absolute value of delta T divided by the thickness, the equation you saw in the previous part. Let's work an example. In the first case, a window, let it be a window. The rate of thermal energy passing through the window is 400 watts. It's calculated using the standard formula shown here, where the R is subscripted 1 to correspond to the first situation. K, the thermal conductivity, is also subscripted, as well as the thickness. No need to put a subscript on the A or the delta T, because in this problem the only things that will be changing are the thermal conductivity and thickness. So no need to differentiate the A's. They'll be the same in the first instance and in the second instance. The same thing can be said about the temperature difference. All right, in the first case, the rate is 400 watts. We ask this question: what if we were to replace that glass with one that had a conductivity that is 3 times the old one, and it's twice as thick? So K2 would be 3 times K1. The new X2 would be 2 times the old X. And so we take these expressions for K2 and X2 and insert them in the rate equation in the second case. Again, you have subscripts on the R, the K, and the X, and no bother to subscript A or delta T because they're the same in both situations. Substituting now for K2, we have 3 times K1, and the rest is the same. For X2, we have twice of X1. So we collect together the 3 and the 2, and we have a multiplier of 3/2 times what's left, which is Ka delta T over X1. Well, the quantity shown here in the parentheses is shown here. Same quantity here versus there. So this quantity being 400 means this quantity in the parentheses is 400. And now one more step. Very simple. 3/2 of 400, 600 watts. Final answer.